Hello, welcome. So today we are going to solve this n points on a circle question from the Green Book. So this is a very interesting problem. Let's discuss. So the question is given n points drawn randomly on the circumference of a circle, what is the probability that they are all within a semicircle? So the solution is a little tricky to understand. So I'll try to convince you of the solution uh, by explaining it in more detail. So let's take a, so we'll start with a simple case of n is equal to 1. So when n is equal to 1, no matter where you choose the point, it is always going to lie on a semicircle, as it is evident from the picture. So the probability would be 1. When n is equal to 2, let me draw the circle again. Yeah, so when n is equal to 2, let's say I put my first point P1 here, and there are two semicircles possible. Now, no matter where I choose my P2 to be, either here or here, it is always going to lie, we will always be able to find a semicircle in which we find both the points. So if we choose P2 here, this is a semicircle where we'll find both the points. If we choose P2 here, then the left semicircle would be where we'll find both the points. So again, probability would be 1. Now let's consider the case n is equal to 3. This is an important case from which we will derive the solution for a general n points case. So when n is equal to 3, let's choose my first point P1 as here. Now P2 has two options. P2 can either lie on the right side of this line or on the left side of the line. So the probability that it appears on the either side of the line would be half, because both the sides are equally symmetrical. So P2 can either come here or it can come here. Similarly for P3 again, it can either come on the right side of the line or the left side of the line. And we will find a semicircle starting with semicircle point P1 and all 3 points on the semicircle with a probability of P2 being on the one side and P3 again being on the one side. So we'll get 1 by 4. I hope how this 1 by 4 is clear, because uh, half is the probability of coming it on the either side of this line. So we want both the points P2 and P3 to be on the one side of the line if P1 is the starting point. Now let's take the case that we chose P2 to be here and P3 to be here. Now this was the probability when we chose P1 as semicircle start point, and we went clockwise and we chose P2, P3 on one side of the semicircle, and we got the probability as 1 by 4. Now what if P2 is the starting point? In case P2 is the starting point, so this would be the line. So again for P2, now we have to place P1 and P3 such that P2, P3 and P1, they lie on a semicircle. So for P2 again, for P3 and P1, the probability is half and half. So again, it would be half times half, and it would be 1 by 4. This is when P2 is the start point of the semicircle. Similarly, we can see that for P3, it would be same thing as for P3. If we want a semicircle starting from P3 and we want P1 and P2 to be on the same side, then again it would be half times half, and it would be 1 by 4. Now an important point here to note is that the there are three events which we listed down. The event 1 with P1 as the starting point, event 2 as P2 as the starting point, and event 3 as P3 as the starting point. Okay, event 1, event 2, event 3. Here P1 is the starting point, and we calculated probability of 1 by 4. Here P2 is the starting point, here P3 is the starting point. Now the claim is that these three events are mutually exclusive. Mutually exclusive events. Now, mutually exclusive events, how can we prove that these three events are mutually exclusive? So, to prove that, let's see the picture once again. If we are saying that if our semicircle start point is P1 and we are able to place points P2 and P3 such that P1, P2 and P3 form a clockwise semicircle, then if we keep the points like this only and we just shift the semicircle start point to another point, let's say P2, then it is guaranteed that we will not be able to find a semicircle with all the 3 points, because now from P2, if I form a semicircle in clockwise direction covering all the points, then it is no longer a semicircle because it covers from here till here. It covers this entire distance, and this is not a semicircle. Similarly, if I keep the 3 points as it is and I move the starting point, semicircle start point to P3, and again if we go in a clockwise direction, we will note that, so if we go in a clockwise direction, we'll go till here till P2. Again, this is not a semicircle. So the point is, the three events in which respective points are the semicircle start point. So when even event 1 happens, event 2 or 3 cannot happen. If event 2 happens, 1, 3 cannot happen. So that is like the basic definition of mutually exclusive events. So the picture of these three events would look something like this. All three events are independent of each other. And for the 3 case, it is evident from the picture. The same is true for n case, for n points case. How is that? Let me draw a picture again. Here, if let's say this is my ith point, and somewhere here there is the first point, somewhere here there is, let's say, the nth point, and this is the I-1 point, and this is in the semicircle direction. We see that all the endpoints form a semicircle, lie on a semicircle. But if we keep so this is the event 1, event I, where the ith point is the semicircle start point. Now if I just if I keep the points as it is, and if I move the semicircle start point to, say, let's say 1. So now this is event 1. How this is event 1? Because now I have kept the point as it is, but I have just moved the semicircle point. So from 1, if I go in the clockwise direction, you will notice that if I try to cover all the points till I point, then this is no longer a semicircle. Thus, this proves that all the n events from I1 to n are going to be mutually exclusive. If we want to find an even event meaning that the semicircle start point is starting from 1, then we will have to place all the n points on either this side of the line or that side of the line. Currently, 1 point is on the left side and the remaining n minus 2 points are on the right side. So, and the probability of each event ei, what will be it? So for any point, there are now n minus 1 points remaining. If let's say this 1 is the starting point of the semicircle, then there are n minus 1 points. And we want all n minus 1 points to be on the one side of this line. And what is the probability for each individual point? It is 1 by 2. And we are saying that this should happen for n minus 1 points. So the probability is 1 upon 2n minus 1. And we have said that our sample space consists of multiple such events from I1 to n, where for n is equal to 3, I showed you this picture. This is a sample space where sample space is E1 plus E2 plus E3. These are the three events, three scenarios in which we will be able to form a semicircle with 3 points on one side. The difference would be that the starting point, the semicircle start point, would just differ. So having said that, so what would be our probability? Our probability would be our sum of all the events, because for mutually exclusive event, probability of all the events is usually is equal to the sum of individual events. So this would be probability of E1 plus probability of E2 till probability of En. And we found that for each Ei, our probability is 1 upon 2 to the power of n minus 1. So 1 upon 2 to the power n minus 1 into there are n such events. So our probability that n points lie on a semicircle is n upon 2 to the power n minus 1. So hope this solution was clear, and let me know if you have any doubts in the comment section. I'll try to resolve it if necessary. So thank you. See you next time with another question.